What would you say? What story would you tell? You might say, well, I come from my hometown, or my city, or my country. If you have a particularly wide perspective, you might say, I come from planet Earth. But what is the largest structure that we could legitimately call home? Well, I would argue it's that faint arc of light that stretches across the sky from horizon to horizon is an outer spiral arm of our galaxy, the Milky Way, our home island, 400 billion stars. The Milky Way takes its name from the dense band of stars that sweeps across the sky on the clearest of nights. From our vantage point here on Earth, we see the galaxy from within. But if we could travel outside the galaxy, we would see the entire structure. The Milky Way revealed as an island of light, surrounded by darkness. Hundreds of billions of stars in a single disk that's existed since the universe was young. Only now are we able to explore its history. How it was born, how, through a series of remarkable events, it grew to become the galaxy we inhabit today, and how, eventually, it will end. We've discovered our own part in this story too, living as we do inside the Milky Way, just over halfway along one of its magnificent arms, around a small but familiar star. The Milky Way is an island in a sense. Every star you can see in the night sky is a part of our galaxy. Our nearest neighbour in large galaxy is over 2 million light years away, so it certainly feels as if we are isolated and alone, adrift in an ocean of dark. And that is true to a point. There is no conceivable technology that will ever allow us to leave our island physically. But science allows us to leave the Milky Way in our imaginations, to view our galaxy from impossible perspectives in both space and time, and to tell its story. One mission more than any other has deepened our understanding of the galaxy. A spacecraft bearing the name of an ancient Greek goddess.
Everything functioning beautifully.
Gaia.
Coming up on separation of the boosters.
Ancestral mother of all life on Earth.
4 boosters, 4 points of light falling away.
Gaia's mission? To map the locations of billions of stars in the Milky Way. Nearly all of them for the first time. Gaia spins on its axis. Its sensors scanning the galaxy in all directions. Every star is mapped an average of 70 times, allowing Gaia to calculate the speed and direction of each one, pinpointing their locations with accuracies up to 1,000th of 1%. Over 1.5 million stars every hour. Almost 2 billion in total so far. To create a map like nothing ever seen before. The Gaia data is by far the most detailed star map ever produced. A revolution in our understanding of the Milky Way. I mean, this is the data, and it looks like an artist's impression of a galaxy, something from science fiction. But this is a high precision 3D map of our home, of our island of stars. And we can even fly through it, such as the precision of the mapping of the position. All these points of light are stars, some of them as far as 30,000 light years out from the solar system. The map allows us to journey through the galaxy at impossible speeds, bringing distant stars within reach. But this is also a journey through time. The extraordinary thing about this map is that it's alive, in a sense. Gaia didn't just measure the positions of these stars, it measured their velocities. And that means we can tell where those stars are going, what the galaxy is going to be like in the future, but also we can tell where they came from, so what the galaxy was like in the past. By reversing the direction of every star, we can rewind their histories, travelling backwards in time through billions of years. Gaia has initiated a new science, a science of galactic archaeology, where we can ask questions about the origins of our galaxy itself. The first galaxies emerged just a few 100 million years after the Big Bang. The universe was crisscrossed by a vast structure known as the cosmic web. Great filaments of dark matter, along which gravity attracted ever denser concentrations of gas, separated by immense tracts of empty space. The first stars were born where the filaments crossed, where the gas was dense enough to collapse under its own gravity, and for the stars to ignite. New stars formed in their billions, bound together by their mutual gravitational pull. These were the first galaxies. Amongst them, the Milky Way, in its embryonic form, far smaller and more irregular in structure than the mature spiral galaxy we inhabit today. The exact details of the Milky Way's birth remain the subject of research. But thanks to modern-day observations, the story of how our galaxy grew from those early beginnings is coming into much sharper relief. The Gaia data allows us to see how the Milky Way evolved throughout its history. And one of the clues that it's had an interesting history can be seen in this animation. You see that most of the stars orbit in very regular orbits around the centre of the Milky Way. That's exactly what you'd expect. But you can see here that some of the stars have very different orbits indeed. They seem to be flying all over the place. And that tells us that something dramatic happened at some point as our galaxy made its way through the universe. Across the universe, hundreds of billions of galaxies were forming. Some, just a few dozen, were born close enough to the Milky Way that their mutual gravitational pull drew them together, forming what we now know as the local group of galaxies, our home archipelago. "6 billion years before the Earth formed, some of the Milky Way stars already had their own planets. Early worlds that were about to witness the transformation of the galaxy. The wonderful thing about astronomy is that you can look up into the sky, and even if you can't see worlds, you can imagine them, and you can imagine their stories. Like over there, close to the bright star Vega, is Kepler 444, a faint ancient star with planets orbiting around it that's witnessed pretty much the entire history of the Milky Way galaxy. And then maybe swing around in the sky, just close to the Plan constellation that everybody can recognize, and follow it down. There's a really faint star there. You can't see it with the naked eye. It's so nondescript, it doesn't even have a name. It's got a number. It's called HD 73394. But that star is an alien star. It was born in another galaxy, and it entered the Milky Way in a galactic collision with a smaller galaxy. And Kepler 444, over there, witnessed it all, and witnessed the Milky Way being thrown into chaos. Kepler 444 was orbited by 5 planets. And something new had appeared in their skies. A smaller galaxy was approaching the Milky Way, with stars that burned bright blue. Gaia Enceladus, a member of the local group, roughly a quarter of the size of our own galaxy. Over hundreds of millions of years, the galaxies collided. The stars of Gaia Enceladus penetrating deep into the Milky Way's heart. But our galaxy held its ground. Capturing billions of incoming stars. An entire galaxy swallowed whole. These alien stars remain in our galaxy to this day. The Gaia data tell us that collisions are the driving force of galactic evolution. Some galaxies cease to exist as independent islands of stars, while others grow and prosper. The survival of the fittest, writ large. Gaia Enceladus, the alien galaxy, had brought with it fresh supplies of interstellar gas, the raw material of star formation. For a time, this gas heightened the rate at which the Milky Way could produce new stars, helping it to grow. But long before our star was born, the Gaia Enceladus collision era drew to a close. What triggered the formation of the Sun has long remained a puzzle. But the Gaia telescope has discovered new clues to its origin in the events that followed billions of years later, as our island of stars continued to evolve. On the distant shores of the Milky Way, Gaia has investigated a structure of epic proportions, a stream of stars winding their way around the galaxy. This stream of stars is enormous. It's almost unimaginable in scale. I mean, look up into the night sky. Those stars that you can see are at most a few thousand light years away. You think about that, the light began its journey to your eye from the most distant stars when the pharaohs ruled Egypt. Then if you look out to the Milky Way, to the shores of our galaxy, you see light from a few tens of thousands of light years away. I mean, that light began its journey when there were Neanderthals here in Europe. But this stream of stars wraps around the galaxy. It's hundreds of thousands of light years in extent. A structure that large demands an explanation. The stream is wreckage, it's footprints, if you like, of a very violent event. Gaia has confirmed the origins of this immense structure. Through the telescope's unique ability to help us travel through time, backwards. The data tell a story of a new age of starbirth. Of the transformation of the Milky Way, triggered by another galactic collision. It was another galaxy from our local group, Sagittarius Dwarf, perhaps 20 times smaller than the Milky Way, was torn apart in the impact. Sagittarius Dwarf brought fresh supplies of the vital ingredient for starbirth. That is the sound of the most common element in the universe. And this radio telescope is pointing towards the Milky Way, which had just risen above the horizon over there behind the clouds. And what you're listening to is hydrogen gas. The radio telescope is detecting the faint signal of hydrogen from across the galaxy. Hydrogen is found throughout the Milky Way, sometimes in the form of towering clouds, light years high. These regions are star factories, where the dense clouds of hydrogen gas collapse under gravity to forge new stars. Hydrogen atoms radiate radio waves at a very particular wavelength, 21 centimeters. And as I speak, that radiation is being captured by that radio telescope. Imagine there are atoms over there. And by over there, I mean what? Thousands, tens of thousands of light years away. At some point, way, way back in the past, out came the radiation and we can listen to it. So we're listening to the lifeblood of our galaxy. As Sagittarius Dwarf passed through the Milky Way, it brought fresh gas and fresh energy. The impact sent ripples across the Milky Way, triggering another spectacular era of star formation. And in the outer regions of the galaxy, our own star was born. The Sun was soon joined by the Earth. and together they set out on their journey through the galaxy. We were born in the Milky Way. But we may have been conceived in a collision. Now, we can't say for certain that the collision with Sagittarius dwarf caused the formation of our sun. The data is not precise enough and our understanding is not deep enough for that. But what we can say is that the birth of the sun coincided with enhanced rates of star formation in the Milky Way caused by that collision. But that's not quite the end of the story, because in a very real sense, the collision is still underway. The remains of Sagittarius dwarf are still orbiting on the fringes of the Milky Way. Over the last 5 billion years, the galaxy has crossed our path 2 more times. Each interaction triggering a new generation of star birth. A fresh sprinkling of light inside our galaxy's spiral arms. The finishing touches on a masterpiece of galactic creation. The poet John Donne famously wrote, "No man is an island entire of itself. Every man is a piece of the continent, part of the main." By which he meant that no human being can isolate themselves from the rest of humanity, because our origins and our fates are so deeply intertwined, and therefore we must care deeply for each other. And the same is true for galaxies. No galaxy is an island entire of itself. And the history of the Milky Way stretches back 13 billion years or more. That's pretty much for the entire history of the universe. And its story is a story of collisions and interactions between galaxies, of rivers and flows and streams of stars stirring up the void and triggering the formation of worlds like ours. You, me, everyone can trace our origins back to a collision between galaxies. You may be small, but you are a consequence of grand events. We move into the future with a new understanding of our place in the galaxy. We are inhabitants of a small planet orbiting around an ordinary star where something extraordinary has happened. But although the galaxy made us, it wasn't made for us. We are accidental byproducts of its history. And we will be passive witnesses to its ongoing evolution. The Milky Way is the great survivor, and the echoes of its turbulent history are literally written across the sky. Over there in the southwest, the remnants of Sagittarius dwarf, the debris from that collision still wandering around somewhere on the fringes of the Milky Way. And in that direction, as Sirius rises in the east in the constellation of Canis Major, there are the remains of another dwarf galaxy that we think collided with us long ago. So the Milky Way pretty much devours anything that comes into this region of space because it's the largest galaxy in the neighbourhood, except for one. The local group is home to another galaxy that rivals our own in size. A galaxy that's been hiding in plain sight. Right up there, just between the constellations of Cassiopeia and the square of Pegasus, is a faint misty patch of light in the sky, about twice the diameter of a full moon, so you can certainly see with binoculars. And even in the city, I can take a photograph of it with a camera like this. And there it is. That object is the Andromeda Galaxy. And you see that it's a spiral shape. You can see it even in this photograph. In many ways, Andromeda is our twin. And it's a twin that we've been able to explore in incredible detail. The Hubble Space Telescope is in its 4th decade of operation. Its ongoing mission has given us some of the most detailed images of the universe ever seen. Over the years, Hubble has frequently turned its attention to Andromeda, 2.5 million light-years from Earth. It's mapped a spiral structure similar to that of the Milky Way, with such fine precision that we've been able to calculate not only the motion of Andromeda's stars, but also the motion of the galaxy itself. And we now know that the entire galaxy is heading towards us at over 400,000 kilometers per hour. Now you may think, well, what's one more collision? I mean, the Milky Way has survived all these collisions for pretty much the entire history of the universe. Well, this one will be different because Andromeda is bigger than us. The Milky Way, as we know it today, will not be immortal, and the Earth will witness its demise. 2 galaxies in a single sky, gradually but inexorably merging into one. In the impact, there will be a last colossal burst of star formation. But this will be very different to previous collisions. This time, our galaxy will meet its match. The great galaxies will distort each other's spiral arms. Stars will be scattered until no traces of the original structures remain. The Milky Way's fate is sealed. Andromeda will be the first of a series of mergers as the remaining galaxies in our local group converge, drawn together by gravity. But Hubble has allowed us to see even further into the future. It's looked out far beyond the local group, towards the edge of the observable universe, and seen that every distant galaxy is receding from us. In a final twist, these retreating galaxies tell us something profound about the nature of the universe itself. We live in an expanding universe. In fact, we live in a universe that's accelerating in its expansion. So all the galaxies are rushing away from each other. And in the far future, they'll be rushing away from each other so fast that even if we sent a beam of light out to the galaxies, it would never catch them. Billions of years from now, the remnants of the Milky Way will form part of a single gigantic collection of stars, the merged remains of the local group, alone as every other galaxy recedes into the distance. Eventually, all the galaxies will fade from view, and our galaxy will stand at last in perfect isolation, an island unto itself. I think we live at a fortunate time in the history of the universe because we can look into the sky and see the galaxies. The astronomers of the far future might imagine that they live in a universe populated by countless billions of islands and billions of stars, but they won't be able to prove it. They won't be able to see the true scale and majesty of the universe.